All right, students, so now we have conditional probability phase 2, and it's really just picking up where we left off in the notes from yesterday. Was getting good at the formula. Just review the formula, how it works. The probability, you need to determine the probability A given B. All right, so probability one event happening, given that another event's already happening. So it's like, think about what's the probability it snows. I always like to talk about snow for some reason, given it's cold. Like, let's say it's less than 30 degrees out. Well, that's going to be different than the probability it just snows, because any given day it snows, probability not that great. Given that it's cold out, the probability increases. It's more likely to snow in the winter, if you've never realized that. All right, and there's some other examples we could think about, like what's the probability it rains when it's warm out? Well, that's going to be different. All right, so you can always think about weather, maybe traffic. What's the probability that there's heavy traffic given that it's rush hour? Well, it's going to be near 100% because the time of the day impacts that, so on and so forth. So the probability of A given B is going to be the probability that both events are happening over the probability that B is already happening. So in this one, it tells you 0.4, 0.6. Just plug those in. It's going to be about 0.67. All right, again, just getting used to the formula. That's all we're doing right here. All right. Ooh, this one's a little different. So we have the probability of H given F. Remember, it's going to be the probability of the intersect over the probability that F is already happening. This time it gives us 0.35, or excuse me, 0.32. The given gives us the given. Gives us that right there. Now we got to calculate the intersect. 0.32 equals the probability H intersect F over 0.5. So it's really just solving for the intersect. So you're going to multiply both sides by 0.5. They're going to cancel out on this right-hand side. So the probability of H intersect F happening is 0.5 times 0.32, which I believe is about 0.16. I'm right, and that's that. All right, so just a little dive back into the formula, very mathematical right there, pure math. Now we're going to do some word problems. Ezekiel is a very average student. The probability that he studies and passes the math test is 7/20. So the probability that he study and passes is 7/20. The probability that he studies is 9/19. Find the probability that Ezekiel passes the math test given that he has studied. All right, so what we need to determine is what's the probability that he passes given that he studies. Well, it's going to be the probability of the intersect over the probability that he studied. So this is when we're going to run in some fractions over a fraction again. Hopefully we're not too scared. So remember, I'm going to change the fraction bar, that symbol, into the other dividing symbol. All I did was rewrite this as that, because then you can remember what we do here is keep, change, flip. So what that means is I'm going to keep the 7/20, change to multiplication, flip the 19/9, and then multiply straight across. You're going to get 7 times 19 is 133 over 180. All right, and that can kind of be meaningless. Sometimes fractions don't help us out too much. What I can convert this to is a decimal or a percentage. This is about 0.74, or a 74% chance of him passing. All right, so the probability he passes the math test was 35%. The probability that he passes given that he has studied goes up to 74%. Weird how that works. He has a better chance of passing the test if he studies. It's almost like I'm trying to hint for you guys to do something for the test that's coming up. Hint, hint, wink, wink. All right, the probability that Cardale wins is 7 out of 10. All right, so the probability Cardale wins is 7 out of 10. The probability that he throws a touchdown and wins, so the probability of throwing a touchdown and wins is 9 out of 13. Find the probability that Cardale throws a touchdown given that he wins. All right, so we need the probability that he scores a touchdown given that he wins. So it's going to be the probability of a touchdown and a win over the probability of a win. So it's going to be 9 over 13 over 7 over 10. Remember, I'm just going to rewrite this fraction over a fraction using the divided by sign. All right, keep, change to multiplication, then flip. We're going to get that. It's going to go over 9 equals 90 over 91. So almost 100% chance that he throws a touchdown during wins. All right, so there's a football example. All right, stay tuned.